Welcome back to our lesson on computer hardware and maintenance. In the last chapter you learned about motherboards, and in this chapter you're going to learn about the two most important components on the motherboard, which are the processor and the memory. You're going to learn how a processor works and about the many different types and brands of processors and how to match a processor to the motherboard. Now, memory technologies have evolved over the years, and when you support an assortment of desktop and notebook computers, you'll be amazed at all the different variations of memory modules used in newer computers and older computers that are still in use. Simple problem of replacing a bad memory module can become a complex research project if you don't have a good grasp of current and past memory technologies. The processor memory modules are considered to be field replaceable units, or what we call FRUs. So you'll learn how to install and upgrade a processor and the memory modules. Upgrading the processor or adding more memory to a system can sometimes greatly improve the system performance. So we need to discuss the different types and characteristics of the processors. Now, the processor installed in the motherboard is the primary component that determines the computing power of the overall system, as you can see here behind me. Now, recall that the two major manufacturers of processors are Intel and AMD. And in this chapter you're going to learn a lot of details about the processors. And as you do, try to keep these 9 features of processors at the forefront. Now, these features affect performance and compatibility with the motherboards. Feature 1, clock speed. The clock speed that the processor supports. Now, current Intel and AMD processors work with system buses that run at 1.8 gigahertz up to more than 3.4 gigahertz. Now, recall from the last chapter that the smaller the processor multiplier, the faster the system bus runs in comparison to the processor speed. Now, feature 2 is the processor speed itself. Now, processor core frequency is measured in gigahertz, such as 3.3 gigahertz. Feature 3, socket and chipset, the processor can use. Now, recall from the previous chapter that important Intel sockets for desktop systems are the PGA 988, the LGA 2011, the LGA 1155, the LGA 1156, 1366, and 775. Now, AMD's important desktop sockets are the AM3 Plus, AM3, AM2 Plus, AM2, the FM1, F, and the 940. Feature 4, processor architecture. We're going to go 32 bits or 64 bits. Now, all desktop and laptop processors sold today are either Intel or AMD, and they're hybrid processors, which can process 64 or 32 bits at a time. But older processors handle only 32 bits. Now, a hybrid processor can use a 32-bit operating system or a 64-bit operating system. Most editions of Windows 7 come in either type. Now, feature 5, multiprocessing abilities. The ability of a system to do more than one thing at a time is accomplished by several means. Multiprocessing. 2 processing units called arithmetic logic units, or ALUs, are installed within a single processor and called multiprocessing, and first used by Pentium processors. The Pentium was the first processor that could execute 2 instructions at the same time. Dual processors. A server motherboard might have 2 processor sockets called dual processors, or a multiprocessor platform, as you can see here behind me. The processor, for example, the Xeon for servers, must support this feature. And then there's multi-core processing. Now, multiple processors can be installed on the same processor housing, called a multi-core processor. Now, the processor package might contain up to 8 cores, dual core, triple core, quad, and so on. Then there's multi-threading. Now, each processor or core processes 2 threads at the same time. And when Windows hands off a task to the CPU, it is called a thread, and it might involve several instructions. Now, to handle 2 threads, the processor requires extra registers, or holding areas, within the processor housing that it uses to switch between threads. Now, in effect, you have 2 logical processors for each physical processor or core. Now, Intel calls this technology hyperthreading, and AMD calls it hypertransport. Now, the feature must be enabled in the BIOS setup. Now, feature 6, memory cache, which is the amount of memory included within the processor package. Now today's processors all have some memory on the processor chip called a die. Now memory on the processor die is called level 1 cache, or L1. Memory in the processor package but not on the processor die is called level 2 cache, or L2. Now some processors use a third cache farther from the processor core but still in the processor package, which is called the L3 or level 3 cache. Now memory used in a memory cache is static RAM or SRAM, and then memory used on a motherboard loses data rapidly and must be refreshed often, so it is therefore called volatile or dynamic RAM, or what we call DRAM. Now SRAM is faster than DRAM because it doesn't need refreshing and it can hold its data as long as power is available. Feature 7, the memory features on a motherboard that the processor can support. Current types of DRAM memory or memory modules used in the motherboard include DDR, DDR2, and DDR3. Now besides the type of memory that a processor can support, it can support certain amounts of memory, and memory speeds, and the number of memory channels. It's single, dual, triple, or quad channels. Now all these characteristics of memory will be discussed later on. Feature 8, support for virtualization. Now if you remember from the earlier chapter that a computer can use software to create and manage multiple virtual machines that contain virtual devices. Most processors sold today support virtualization, and the feature must be enabled in BIOS setup. Feature 9, integrated graphics. A processor might include an integrated GPU, a graphics processing unit. Now this is a processor that manipulates graphic data to form the images on the monitor screen, like you're seeing now. Now the GPU might be on a video card on the motherboard or embedded on a CPU package. Now when inside the CPU package, it is called an integrated graphics. Now many AMD processors and all the Intel 2nd generation Sandy Bridge and 3rd generation Ivy Bridge processors have integrated graphics. Now an A+ exam tip, the A+ 22801 exam expects you to be familiar with the characteristics of processors. Know the purposes and characteristics of hyperthreading, core processing, types of cache, virtualization, integrated GPU, and 32-bit versus 64-bit processing. So now let's turn our attention to a discussion on how a processor works, including several of the processor features that we just talked about. Then you'll learn about the families of Intel and AMD processors. So let's get started. Now although processors continue to evolve, they all have some common elements, and these elements are diagrammed here behind me. Now for the Pentium processor, the Pentium made several major advances in processor technologies when it was first introduced. Now because of its historical significance and the foundation that it created for today's processors, it's a great place to start when we're learning about how a processor works. Now a processor contains these basic components, which are diagrammed here behind me. Now for the Pentium processor, an input-output unit manages the data and the instructions entering and leaving the processor. And then a control unit manages all the activities inside the processor itself. Now, one or more of these arithmetic logical units, or ALUs, do all the logical comparisons and calculations inside the processor. All desktop and laptop processors sold today contain 2 ALUs in each processor core within the processor package. Now registers, which are small holding areas on the processor chip, work much like RAM does outside the processor to hold the counters, the data, and instructions, and the addresses that the ALU is currently processing. Now internal memory caches, L1, 2, and maybe even the 3, will hold data and the instructions waiting to be processed by the ALU. Buses inside the processor connect the components within the processor housing. Now these buses run at a much higher frequency than the front side bus, or FSB, that connects the processor to the chipset and the memory on the motherboard. Now, the speed at which the processor operates internally is called the processor frequency. So for example, if the processor operates at 3.2 gigahertz internally, but the front side bus is operating at 800 megahertz, the processor operates at 4 times the FSB speed. Now this factor is called the multiplier. Now, as we talked about earlier, you can view the actual processor frequency and clock speed using the BIOS setup screens. You can also change the multiplier or the clock speed in order to overclock or throttle the processor. Now you should also remember that I did tell you before, this is not a good practice because overclocking your processor can only lead to greater heat. And if you're not cooling your computer down, you can end up torching your motherboard. Now, as you can see behind me, the internal data bus for the Pentium was only 32 bits wide. More important, however, than the width of the internal bus is the fact that each ALU and register in the early Pentiums could process only 32 bits at a time. All desktop and laptop processors sold today from either Intel or AMD contain ALUs and registers that can process 32 or 64 bits at a time. Now, to know which type of operating system to install, you need to be aware of 3 categories of processors currently used on desktop and laptop computers. 32-bit processors. These older processors are known as x86 because Intel used the number 86 in the model number of these processors. Now, if you're ever called on to install Windows on one of these old Pentium computers, you must use a 32-bit version of Windows. Now, these processors can handle only 32-bit instructions from the OS. Processors that can process 32 or 64, these hybrid processors, are known as x86 or 64-bit processors, and we spoke about this earlier as well. AMD was the first to produce one, the Athlon 64, and called the technology AMD 64. Intel followed with the version of the Pentium 4 processor, and they called it the EMT64T. Or EM64T. Because of their hybrid nature, these processors can handle a 32-bit OS or a 64, and we spoke about that earlier as well. Now, all desktop or laptop processors made after 2007 are of this type, 64-bit processors. Intel makes several 64-bit processors for workstations or servers, and these use fully implemented 64-bit processing, and including the Itanium and Xeon processors. Intel calls the technology IA64, but they are also called x64 processors. They require a 64-bit operating system and can handle 32-bit applications only by simulating 32-bit processing. Each corner processor has its own cache and can also share a cache. As the figure behind me shows how a quad-core processor can work if the processor uses an L3 cache and an internal memory controller. Each core within a processor has its own independent internal L1 and L2 cache. The L1 cache is on the die and the L2 is just off the die. In addition, all the cores might share an L3 cache with the processor package. Now, if you recall from our earlier chapters that prior to the memory controller being in the processor package, it was part of something called the Northbridge chipset. Now, putting the controller inside the processor package resulted in a significant increase in system performance. Intel processors, Intel's current families of processors for the desktop, include the Core, Atom, Celeron, and Pentium families of processors. In addition, Intel groups its processors into 3rd generation, 2nd generation, and previous generation processors. Each generation improves on how the processor and chipset are integrated into the system. Processors in each family are listed in the table behind me, and some significant retired processors are also listed. Now, later on, I'll talk about the memory technologies that were mentioned in the table. An Intel Sandy Bridge Core i5 processor is known as shown here behind me. You can purchase the processor with or without the cooler. Now, when it's purchased with a cooler, it's called a box processor, and the cooler is also shown in the photo behind me. Now, if you purchase the cooler separately, make sure that it fits the socket that you're using. Each processor listed in the table that we talked about, that we showed you earlier, represents several processors that vary in performance and functionality. Now, to help identify a processor, Intel uses a processor number. For example, 2 core i7 processors are identified as i7 940 and i7 920. Now to find details about an Intel processor, search the Intel ARC database at arc.intel.com. Now some of the Intel mobile processors are packaged in the Centrino processor technology using the Centrino technology. The Intel processor chipset and wireless network adapter are all interconnected as a unit, which improves laptop performance. Several Intel mobile processors have been packaged as a Centrino processor. You also need to be aware of the Intel Atom processor, which is Intel's smallest processor and is used in low-cost PCs, laptops, netbooks, and tablets. AMD's processors by Advanced Micro Devices Incorporated, or AMD, are popular in the game and hobbyist markets and are generally less expensive than the comparable Intel processors. Now recall that AMD processors use different sockets than do the Intel processors, so the motherboard must be designed for one manufacturer's processor or the other, but not both. Now many motherboard manufacturers offer 2 comparable boards, one for the Intel, one for the AMD. Now the current AMD processor families are the FX Phenom, Athlon, Sempron for the desktops, and the Athlon Turion, V-Series Phenom, and Sempron for the laptops. Now as the graphic shows behind me, it has the current AMD processors for the desktops. And then the next figure shows an FX processor by AMD. Now, in the next part of the chapter, you're going to learn about the detailed steps to select and install a processor in several of the popular Intel and AMD sockets that are used by a desktop computer. So let's move along on selecting and installing a processor. Now, a PC repair technician is sometimes called on to assemble a PC from parts. Maybe exchange a processor that is faulty, add a second processor to a dual processor system, or upgrade an existing processor to improve performance. Now in each situation, it is necessary to know how to match a processor for the system in which it is installed. And then you need to know how to install the processor on the motherboard for each of the current Intel and AMD sockets used for desktop and laptop systems. Now in this part of the chapter, you're going to learn about selecting and installing processors in desktops. Later on, you're going to learn about selecting and installing processors in laptops. Select a processor to match the system needs. So when you're selecting a processor, the first requirement is to select one that the motherboard is designed to support. Among the processors the board supports, you need to select the best one that meets the general requirements of the system and the user's needs. Now to get the best performance, use the highest performing processor the board supports. However, sometimes you need to sacrifice performance for cost. So let's look at installing that processor. And let's get details of installing a processor in an Intel LGA 1155, 1366, 755, and the AM2 Plus sockets. Now, installing the Intel processor in a socket 1155, LGA 1155, we're going to install the Intel Core i5-2320 processor in the socket 1155. As you can see here behind me in the photo, the socket has a protective cover in its place. Obviously, we're going to be taking that off. So when we're building a new system, if the motherboard is not already installed in the case, follow directions on the motherboard manufacturer to install the motherboard, and then the processor, or to install the processor and then the motherboard. Personally, I like to put everything together on the motherboard and then put it into place. Now the order of installation varies among different manufacturers, so when you're replacing a processor in an existing system, power down the system, unplug the power cord, press the power button to drain the system of its power, and then open the case. Follow these steps to install the processor and the cooler using the LGA 1155 socket. 1. Read all the instructions in the motherboard user guide and carefully follow them in order. No shortcuts. Use a ground bracelet or anti-static gloves to protect that processor, motherboard, and any other components against electrostatic discharge. 3. Open the socket by pushing down on the socket lever or gently pushing it away from the socket to lift the lever. Remove the socket's protective covering. Keep this cover in a safe place, and if you ever remove the processor, put the cover back in the socket to protect the socket. And when the socket is exposed, be careful not to touch the pins in the socket. Remove the protective cover from the processor. You can see the processor in this clear plastic cover on the right hand side of the figure. Now, which also shows the open socket. Now, while the processor contacts are exposed, take extreme care not to touch the bottom of the processor. Hold it by its edges. It's best to use anti-static gloves as you work, but the gloves will make it difficult to handle the processor. Put the processor cover in a safe place and then use it to protect the processor if you ever have to remove it later on. Hold the processor with your index finger and thumb and orient the processor so that the gold triangle of the corner of the processor lines up with the right angle mark embedded on the motherboard just outside the corner of the socket. Gently lower the processor straight down into the socket. Don't allow the processor to tilt, slide, or shift as you put it into the socket. To protect the pads, it needs to go straight down into the socket. Next, you want to check carefully to make sure the processor is aligned correctly in the socket. Closing the socket without the processor fully seated can destroy the socket. As you can see behind me, the graphic shows the processor fully seated in the socket. Now close the socket load plate so that it catches under the screw head of at the front of the socket. Push down on the lever and gently return it to its locked position. Now we're ready to install the cooler. Now before installing the cooler, read the directions carefully and make sure that you understand them. Clips that hold the fan and the heatsink to the processor frame or housing are sometimes difficult to install, and they don't all work out the same. It really depends on make and manufacturer. Now directions might give you important tips, so follow these general steps. The motherboard has 4 holes to anchor the cooler. You can see them labeled in the graphic behind me. Now examine the cooler posts that fit over these holes, and the clip screws, or the wires that will hold the cooler firmly in place. Make sure you understand how the mechanism works. If the cooler has thermal compound pre-applied, remove the plastic from the compound. If the cooler does not have thermal compound applied, put a small dot of compound, about the size of a small pea, in the center of the processor. When the cooler is attached and the processor is running, the compound spreads over the surface. Don't use too much, just enough to later create a thin layer. If you use too much compound, it can slide off the housing and damage the processor or circuits on the motherboard. To get just the right amount, you can buy individual packets that each contain a single application of the thermal compound. Now verify the locking pins on the cooler are turned as far as they will go in a counterclockwise direction. Make sure that the pins don't protrude into the hollow plastic posts that go down into the motherboard holes. Align the cooler over the processor so that all 4 posts fit into the 4 holes in the motherboard and the fan power cord can reach the fan header on the motherboard. Push down on each locking pin until you hear it pop into the hole. To help keep the cooler balanced and in position, push down 2 opposite pins and then push the remaining 2 pins in place. Using a flathead screwdriver, turn the locking pin clockwise to secure it. Later, if you need to remove the cooler, turn each locking pin counterclockwise to release it from the hole. Connect the power cord from the cooler fan to the motherboard power connector near the processor. After the processor and cooler are installed and the motherboard is installed in the case, make sure cables and cords don't obstruct fans to the airflow, especially airflow around the processor and video card. Use cable ties to tie cords and cables up and out of the way. Make one last check to verify all power connectors are in place and other cords and cables connected to the motherboard are correctly done. You are now ready to plug back up the system, turn it on, and verify that everything is working. The power comes on and you hear the fan spinning and see lights, but the system fails to work. Most likely the processor is not seated solidly in the socket, or some power cord has not yet been connected, or it's not solidly connected. Turn everything off, unplug the power cord, Press the power button to drain your power, open the case, and then recheck your installation. If the system comes up and begins a boot process but suddenly turns off before the boot is complete, most likely the processor is overheating because the cooler is not installed correctly. Turn everything off, unplug the power cord, press the power button to drain the power, open the case, verify that the cooler is securely seated and connected. Sometimes just simply wiggling the cooler back and forth will tell you that it is still loose. It shouldn't move at all. After the system's up and running, you can check BIOS setup to verify that the system recognized the processor correctly. The setup screen for one processor is shown here behind me. Now look for systems on that screen that manage processor features and make sure that each is set correctly. For example, in the figure behind me, the items listed in blue can be changed. So verify that it's two blue items that apply to the processor. Verify that all processor cores are active and hyper-threading technology has been enabled. Also, check in the BIOS setup and CPU and motherboard temperatures to verify the computer is not overheating. For one BIOS setup in another system, the screen is under the configuration menu. Fan control and real-time monitoring can be seen here behind me in the graphic. Now if you see the processor temperature is rising and reaching 80 degrees, open the case cover and verify the processor fan is running. Perhaps a wire is in the way and preventing the fan from turning on, or the fan wire is not connected properly. Other troubleshooting tips and processes are covered later on. Now installing an Intel processor in a socket 1366, the installations of all the processors and sockets in this part of the chapter are similar to that of installing a processor in 1155, so that we're not going to repeat any of those steps. Now listed next are the differences when installing a processor in the 1366. These socket pins are delicate, so work slowly and take care. Now here's how to work with the socket. 1. Open the socket, press down on the socket lever, and or to open the socket, press down on the socket lever and gently push it away from the socket. Now you can then lift the socket load plate and then remove the socket protective cover. To install the processor, hold the processor with the index finger and thumb and then orient the processor so that the notches on the two edges of the processor line up in the two posts on the socket. You can see the notch in the posts on the right hand side of the sockets. So gently lower the processor straight down into the socket. Don't allow it to tilt, slide, or shift as you put it in the socket. To protect the pins, it needs to go straight down into the socket. You can now lower the socket load plate and return the lever to its locked position. Now installing the socket 775 along with the depending processor and the cooler. The socket is, you see behind me, in the photo, the socket is open and the protective cover has been removed. The processor is lying upside down in front of the cooler. So now installing a processor for the 775, push down the lever and gently push it away from the socket to lift it. Lift the socket load plate, remove the socket protective cover, orient the processor so that the notches on the two edges of the processor line up with the two notches on the socket. Gently place the processor in the socket. The LGA 775 doesn't have those delicate pins that the 1366 has, but you still need to be careful not to touch the top of the socket or the bottom of the processor as you work. Close the socket cover, push down on the lever, and gently return to its locked position. Done. Now, working with the AMD. The AMD processors, the AM2 processor. So when you're installing the AMD processor, an AM2 or AM2 Plus or other AMD sockets, open the socket lever. If there's a protective cover over the socket, remove it. Holding the processor very carefully so you don't touch the bottom, orient the 4 empty positions on the bottom with the 4 empty positions in the socket. For some AMD sockets, a gold triangle on the one corner of the processor will match up with a small triangle on the corner of the socket. Lower the processor into the socket. Don't allow it to tilt slide as it goes into the processor socket. The pins at the bottom of the processor are very delicate, so please take care as you work. Check carefully to make sure the pins in the processor are sitting slightly into the holes. Make sure the pins are not offset from the holes. And if you try to use the lever to put pressure on these pins and they're not aligned correctly, you can destroy that processor. You can actually feel the pins settle into place when you're lowering the processor into the socket correctly. Press the lever down and then gently into position. You're now ready to apply the thermal compound and install the cooler assembly. For one system, the black retention mechanism for the cooler is already installed on the motherboard. Sit the cooler on top of the processor, aligning it inside the retention mechanism. Next, you want to clip into place the clipping mechanism on one side of the cooler. Push down firmly on the clip on the opposite side of the cooler assembly, and then the clip will snap into place. The figure behind me shows the clip on one side in place for a system that has a yellow retention mechanism and a black cooler clip. Later, if you need to remove the cooler, use a Phillips screwdriver to remove the screws holding the retention mechanism into place. Then remove the retention mechanism along with the entire cooler assembly. Connect the power cord from the fan to the 4-pin fan header on the motherboard next to the CPU. Now, I'm not going to tell you that AMD is better than Intel or Intel is better than AMD, but that was all we need to learn about doing the AMD processors. A lot less headaches, in my opinion, working with the AMDs versus working with the Intel. So that's all we have for this piece. So go online to the online management system, complete any labs that I have hosted for you there, or post for you there. That would be the Chapter 5, Applying Your Concepts, the Hands-On Project 5.1 and 2, and then come on back and then we'll talk about the different memory technologies. So see ya and good luck.